Hi, this is Professor David Farina. In today's lecture, we're going to be talking about telescopes and specifically telescope size. So telescopes are, of course, in many different sizes, and if you've ever wondered why, we're going to talk about that today. Let's get started. So telescope size has a number of different advantages. The larger a telescope is, the more light gathering power it has. So you can think of light gathering power as our ability to enhance our dim objects that we're looking at in the night sky. Now think about an owl. Do owls have big or small eyes? Well, of course. Their eyes are huge. And why is this? Well, yeah, they live at night. They're nocturnal. They're up when it's dark outside, and so they're adapted to seeing in those very low light conditions. So with a telescope, we have basically an attachment that is connected to your eye or a camera, and the bigger that telescope's aperture, or the diameter of its mirror or lens, the more resolving power it has and the more light gathering power it has. Two of the most important features of telescope size. Now, what's better than one telescope? Two telescopes, or three telescopes, of course. So here we have the Keck telescopes, which are up on top of Mauna Kea in Hawaii, along with a number of other scopes here: Subaru, the NASA Infrared Telescope, Canada, France, Hawaii Telescope, and then Gemini North and the United Kingdom's Infrared Telescope. And the Keck telescopes here are connected together by a building. Do you see this? And inside of this building, they actually can combine the light paths of both of these telescopes to produce a single image. In other words, we're combining the light gathering power of one plus the other one. So we get twice the amount of light gathering power. The VLT, the Very Large Telescope in Atacama Desert, Chile, is capable of combining from even more telescopes. Now, there are 4 telescopes here, 1, 2, 3, and 4, and each of these telescopes is capable of combining its light together in a single building. Now, generally, they only operate 3 of the telescopes at a time, and the 4th one is under maintenance. And so they rotate their maintenance schedule around and always have 3 telescopes to work with. The second telescope power is the resolving power. So a low resolution image might look like this in this picture, and the same object in the second picture, highly detailed. So resolving power, the bigger our telescope is, the more resolving power we get. Now, the basic way that this works, the equation for resolving power, is that the resolving power is equal to, in arc minutes, now this is like the angle in the sky that you see, the smaller this number, the higher the resolving power. So it's this is with visible light, it's 1.22 times the wavelength in nanometers of the light that's coming in, divided by the diameter in centimeters of the telescope. So, for example, we've got approximately 11.6 arc seconds to 13.8 arc seconds of resolution that we can use here, and this is what we see in the wavelengths of visible light. So visible light ranges from blue side of the spectrum, which is about 400 or so nanometers. So when we plug the nanometers equation in, 1.22 times about 400, we get 11.6, to just over 700 nanometers. So you take 1.22 times 700, and you get this 13.8 arc seconds. So resolution is proportional to the wavelength and inversely proportional to the telescope size. So once again, if the telescope's diameter is bigger, then this number is going to be smaller, which is good. That's what you want. If this number is smaller, then this whole thing becomes bigger, which means we have less resolving power. So we want this D to be as big as possible. And what we're able to do then is separate what looks like one light source into two separate light sources or more. So this is the effect of improving resolution. This is a 10 arc minute. This is 1 arc minute. And then this is 5 arc second. 10, 1, 5 arc second. And then this is even better. So that's our discussion on telescope size. Thanks for watching the video. If you like this video, please like and subscribe. If you'd like to get a notification every time I make a video, please click that bell at the bottom. Thanks again and have a stellar rest of your day.